Welcome back to Transcended. In today's tutorial, we are going to talk about set theory questions, and I have a lot of questions under this topic, that is set theory. As you can see, these are the questions that we are going to solve. All these questions, we are going to solve them today. Okay, so I have 21 questions, and these are the most interesting questions. So now I have got set theory. In between, there is function. We have function questions. We have also inequalities. We have also modulus equation and also modulus functions, as well as binary operation. So let's not waste our time. Let's begin our discussion with the first question.
In this video, we're going to discuss questions based on set theory as well as an introduction to functions. So if you are new to these topics, this is your video. So I've got all the questions that you need to know under set theory. So the first question here reads, given that U, that is the universal set, has got elements starting from -2 all the way up to 20. Then it has got subsets. So subset X is saying even numbers in the universal set. Then Y is saying prime numbers in the universal set. Z is saying whole numbers in the universal set. Then B has got natural numbers less than 19. Then C has got integers starting from -2 all the way up to 17, or the universal set. So the question is saying list the elements and the cardinality of the following sets. So before we start answering this question, let's first come up with the actual elements of these subsets which we have. So let's start with set X. So set X is saying even numbers in the universal set. So what is an even number? So an even number, this is a number which is divisible by 2. A number which is divisible by 2 and it does not leave the remainder. So it includes both positive and negative numbers. So from this universal set, even numbers is going to be numbers starting from -2. Next is going to be 0 is an even number. Next is going to be 0. Then we have 2, then 4, 6, 8, 10, 12, 14, 16, then 18. The last one is going to be 20. Because the universal set ends on 20. So this is going to be set X. Then we also have got set Y. So set Y, we are saying set Y has got prime numbers in the universal set. So what is a prime number? So a prime number, this is a positive integer which is divisible by 1 and itself only. So it is divisible by 1 and itself only, but 1 is not included. So elements of set Y, they are going to be starting from 2, then 3, 5, 7, 11, 13, 17, and 19. So a number which is divisible by 1 and itself only, that is a prime number, and it has to be a positive number for that case. Then we also have got set Z. So Z, we are saying that Z has got whole numbers of the universal set. So what are whole numbers? So whole numbers start from 0, 0, 1, 2, 3, up to wherever you can end. So Z is going to be 0, 1, 2, then all the way up to 20. So every number starting from 0, that is a whole number. Then we also have got set B. So B is saying X is a member of natural numbers, but less than 19. So 19 is not included. So what are natural numbers? So natural numbers, these are counting numbers, positive counting numbers. So that is set B will be equal to, so positive counting numbers, so 1, then 2, 3, all the way up to 20. These are going to be natural numbers. So that will be set B. No, so not up to 20, because we are saying less than 19. So all the way up to 18, because 19 is not included in the set, because we are using the symbol less than. If it was less than or equal to, we are going to include 19 as well. So that would be B. Then what of C? So C, we are saying that X is a member of integers. So integers, these are whole numbers, both positive and negative. So in this case, we have got the universal set starts from -1 up to 20. So Z is saying, or set C is saying, starting from -2 all the way up to 17. So it's going to be every member, every element is starting from -2, -2, -1, 0, all the way up to 17 is included now. So all the way up to 17. So this is these are the sets which we have. So now that we have listed the sets, we can answer these questions. We can answer these questions. So remember that the question is list the elements under the cardinality or the foreign set. So cardinality simply means the number of elements in that set, the total number of elements in the set. So it's given by the formula, which is modulus of A equal to n, where n is the total number of elements in that particular set. So this one only applies if the set is finite. That is, the set is ending. It does not apply to infinity. So if the set is infinity, you also apply a different formula. But what we have here, all these affinities, because they end, you can see that the universal set is ending at 20 and starting from -2. So we're going to apply that formula to calculate for the number of elements for each and every set. So let's start with the first set, which is saying X union Y. So X union Y. So union simply means add. So that is add the element in X as well as in Y. So what are we going to get? So if we add X, so X has got elements starting from -2. Okay, this has got even numbers. Then Y has got prime numbers. So if we add these, what are we going to get? So we're going to have, so this is going to be equal to, so the element that we're going to have, just add the elements in X as well as in Y. So the element which is found both in X and Y, you just list it once. A good example can be, do we have an element like 2? So 2 is common in X as well as Y. So in short, this set is going to be starting from -2. Next, we are going to have 0, then 2, 3, 4, 5, 6, all the way. So all the way up to 20. So this is going to be set. This is going to be X union Y. So just add the elements in X as well as in Y. That is what union means. Simply add. Then we go to the next question. So we have X intersection Y, complement. So complement simply means elements which are not found in that set. So elements which are not found in that set. So we can start by listing the elements which are found in X and Y. So we have set X here and set Y. Let's list the elements which are found both in X as well as in Y. So we are going to have, so we are saying that X intersection Y, you start by listing this. So X intersection Y, elements which are common in these two sets. So we have 2 here and 2 there. What else? Only 2 is common in these sets. So X intersection Y simply is 2. So now when we say complement, so now we are saying elements which are not found in X intersection Y. So X intersection Y, we just have 2. So what is going to be X intersection Y? Complement, element which are not found in X intersection Y. So this is going to be every element which remains in X as well as Y, excluding the element which is found both in X and Y. So we're just going to exclude 2, but everything else will be included in X intersection Y. These elements are in X as well as Y, but they are not in both of these two sets. So that is going to be elements negative 2, then 0, 3, 4, 5, so on up to 20. So this is going to be the answer to x intersection y complement. Simply elements which are not found in x as well as y. So that would be the answer to question 2. Okay, so there's one thing which we forgot, the cardinality. So for each and every set you have to state the cardinality. So you just have to count how many elements are you going to have, how many numbers elements are you going to have in that particular set. So for this one we're going to say cardinality, which is given by this, equal to n. Then we're going to say cardinality will be equal to, so how many elements are we going to have? So 0. In short, just count all the elements which we're going to have here. So we can count 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is going to be equal to 18. It means you would have answered that question or that part. So you have answered both, listing the elements as well as stating the cardinality. Then let's deal with this question, which is question 3. So we have x intersection open bracket y z. So this symbol simply means the difference of the set. So when we say y z, we simply means y minus z. So elements which are found in x, or elements which are found in y but they are not found in z. That is what that means. That's why you can also write it like this. But again, in mathematics, when two sets are subtracting, it simply means this is the same as y intersection z complement. This simply means that elements which are found in y but they are not found in z. That's what it means. So when you see this symbol, it simply means difference of sets. So subtract elements which are found in the set which is coming first, but not in the set which is coming second. So that's what it means. So let's answer this question. So we are saying we have elements which are found in x. So we already have x. X is this one here. So we are going to keep that, but let's first find this. So we have y, this z. So we are saying that this is the difference of the set. So y minus z. So elements which are found in y but they are not found in z. So we have y here and z is there. So which elements are found in y but they are not in z? So let's check out. So z has got whole numbers 0 all the way up to 20. So which elements are not found in z? So we're going to say this will be equal to open bracket. So elements which are in y but not in z. So we have 2 is in y but not in z. No, it's there. Then 3 is also in z. 5, 7, 11, 13. So this simply means it's going to be an empty set. We don't have elements which are in y but not in z. So all the elements which are in y, they are also in z. So that means it's going to be an empty set. So empty set is denoted by that. So that is the symbol for empty set. So which means that here now what we have is we are saying this such that is equal to empty set. So we are saying that now let's intersect this with x. So x intersect empty set. What are we going to have? Which elements are common in x as well as in an empty set? So we can't have common elements we can't have elements which are common in the given set and a set which you have nothing. So this is also going to be an empty set. So this will be equal to an empty set. So this is going to be the answer to part 3 there. So if you are to state the cardinality here, so we're going to say cardinality will be equal to 0 because we don't have any elements here in this So that's what it means. So So having understood that, you can answer the remaining questions here. You can answer the remaining questions. So when we say B union C will be the same as the first part, which was saying X union Y. Simply add elements in B as well as in C. Then that's your answer. Then Z union C complement. So here we are saying combine the elements in Z and U. Then the elements which are not found in Z and U, but they are in the universal set, that is going to be your answer. So if we combine Z and U, and C, what are we going to have? So we have Z is here, which are whole numbers, and where is C? C is there. So in short, if you look at Z and C, if you combine Z and C, you are going to get the universal set. So you are going to get the universal set. So now we are saying elements which are not found in these two when you combine. What are you going to have? So you are going to have nothing. So that is also going to be an empty set. That simply means add these two sets. When you add elements which are not found in these two sets, but they're in the universal set. So we are saying when you add Z and C, you are going to get back the universal set. So the universal, no. Are we going to get back the yes, because C goes all the way up to 20. Then Z goes all the way up to 20, whereas C starts as low as -2. So if we add these two, we're going to get the universal set. So simply means that is going to be an empty set as well. So that is a question question 5. Then question 6 is saying X complement union. So this one we have to simplify first before you answer. So we are saying C complement union B, then complement outside. So when you see this, it simply means complement, but you can also write it as that. They also mean the same. So when you have got a complement and a complement inside, you are allowed to multiply this complement outside and that inside. So a complement and a complement, they cancel. It's more like you're multiplying negative, multiplied by negative, you're going to get a positive. So in this case, what we are going to do is, we are going to say this complement multiplied by that complement. So we're just going to have C. Then this union is now going to change to intersection. Always when I multiply a complement from outside with inside elements, what we have here is going to change. If it was union, it would be intersection. If it was intersection, it would be union. Then this is going to be B, the complement will come here. So simply means that part 6 is C intersection B complement. So what does this mean? What it means is that first you have to list elements of which are not found in B. Where is B? B we have got elements starting from 1 all the way up to 18. So meaning that B complement is going to be elements which are in the universal set but they are not in B. So elements which are in the universal set but are not in B, we are going to have -2, -1, 0, then also 19 and 20. So this is going to be B complement. So now we are saying find B intersection, C intersection B complement. That is find the element which are found in C, but those elements are also in B complement. So which elements are going to be those? So C intersection B complement is going to be equal to, where is C? So we have C here. C has got elements starting from -2 all the way up to 17. So which elements are common? As you can see, we have -2. So we have -2, -1. These elements are found in both, as well as 0. Then 0 also, yeah. So 17 is not in B complement, whereas 19 and 20, they are not in C. So only these. So this is going to be your answer to part 6 there. So now state the cardinality of this set. So cardinality is going to be equal to n. So how many elements do we have there? If you can count, we have 1, 2, 3 elements. So cardinality is going to be 3. So this is how you can answer these questions. Then if you come to the last part here, we are saying B union C intersection Z. So first of all, start with B union C. Simply add the elements in B as well as in C. So earlier you already had B union C. You already had find this. So now Find the elements which are common in B, and C, and also in Z. That is going to be your final answer. So that is how you can answer this question. Then the second question is saying, let X, so we have got negative 10 to 10, be the universal set. A, we have got negative 1 to 4, B, 0 to 9, C, negative 3 to 6, be the subsets of X. Find each of the following and display them on the real line. So real line also simply means the number line. So we have to display our solutions on the number line. So here there are things which you have to consider when answering such kind of a question. As you can see, we are going to have this scale bracket as well as something like this or that. So where you see this scale bracket, what it means is that not included, okay? It means the same. These two, they mean the same, not included. Then where you are going to see these two, this simply means included. So these two simply means included. So before you start answering questions here, you have to pay particular attention to which symbol has been used. So if we say, like the universal set, we are saying starting from negative 10 all the way up to 10. So if you see here, we have got this scale bracket and that one. So what is the difference between the two? So this one simply means the starting number here, negative 10, is not included. Okay, it's not part of the universal set. Whereas where we are going to end, we have got that symbol. So this simply means that this 10 is included. Okay, so where you see that symbol, we are going to say it's open, meaning that not included. Where you see these two symbols here, it means it's closed. So meaning that if you want to present your solution on the number line, you are going to say, if we have the real line here, then we list the numbers. Let's say we have these numbers here, for instance. Then let's say we have 3, 6, 9, 12, and 15. Then we are saying a particular set is 3, 9. So when presenting this on the number line, you can see that 3 is not included, 3 is not included, 9 is also not included. So it's open. So it's going to be open at the 3 as well as also open at 9. Then you join these two. So that is going to be your answer. You would have answered this question and you have presented it on the number line. If you have something like, let's say 9 all the way up to 12, this one is going to be, you can see that it's including 9. So it's going to be closed at 9 and open at 12. 12 is not included. So when presenting on the number line, you are going to shade. So closed is going to be shaded like that. And open at 12. 12 is not included. So you join like that. It means your answer would have been like that. So pay particular attention to what symbol has been used. Is it open or closed? Okay. So we have the universal set. So in answering these questions, we are going to, let's have the number line or the universal set. So you are going to have the number line or the universal set. So the universal set has got elements starting from 10, not included, all the way up to, negative 10, not included, all the way up to 10. That is our universal set, all the way up to 10. Then, so we have negative 10, then all the way up to 10. So what we're going to do now, we are going just to list, instead of listing all the elements here, starting from negative 10 all to 10, that is going to be tedious. So what we are going to do, you only put the numbers on the line which you have here. Let's say A has got negative 1 to 4. So we have to include negative 1. We also got negative 3. That's all. So it means I can include, let's say, here we have negative 3. Then we also have got negative 1. What else? So positive numbers, we have got 4, 6, and 10 itself. So let's say here we have got 4. Then there we have got 6. So this is the universal set. You don't have to list all the elements of the universal set. Let's say negative 10, negative 9, all the way up to positive 10. No, that is going to be so tiresome. You may not even have enough space. So just put the numbers which you have in the questions given, including those in the subset. So as you can see, we have negative 1, 4, negative 3, 6, as well as those. So these numbers are enough to help us to answer all these questions which we have here. So what we have here, this is the universal set. So let's answer the first question. So the first question is saying A complement. So that is A complement. So what does A complement mean? So A complement simply means elements which are not found in A. Elements which are not found in A. But what is A? So A, we have got elements starting from negative 1 all the way to 4. So A, we have element starting from negative 1 included and all the way up to 4. So you are starting from here all the way up to 4. Both closed because both of them are included. So it will be closed at both negative 1 and as well as 4. So that is A. But the question that is not asking us to find A, it's asking us to find A complement. That is, we have to find elements which are not found in A. So elements which are not found in A but are in the universal set. So it's going to be starting from this same 4. So now 4 is in A, so it can't be in A complement. So it will be open at 4 all the way up to 10. 10 is part of the universal set, so it's going to be closed there. So this is going to be all the way up to there. So this is going to be all the way up to there. Then also negative 1 is in A, so it can be in A complement. And negative 10 is not in the universal set. So this is also going to be A complement. So we have, this is A complement. This is also A complement. So if we are to answer this without using a line, we are going to say A complement will be equal to negative 10 not included all the way to negative 1 not included union 4 not included all the way to 10. 10 is included like this. So this is going to be the answer. And present it on the number line, you are going to present it the way I have presented there. But again, if you want, you can extract and present this on its own number line. So what you can do is you're going to say the number line to this is going to be then here also I'll just list the elements of interest. So we have negative 10, then we have negative 1, we have 4 as well as positive 10. So negative 10, then negative 1, 4 and 10. So now I want to present just that on the number line. So we are going to say this is we're going to say A complement is going to be 10 not included, 1 also not included. We join this. Union 4 is not included, but 10 is included. Then we join this. So this is the answer on the real line. That is A complement. So that is how you can present your answer on the real line. Okay. So always pay particular attention. If this was also kept like that, we are going to say open at 10. This was not going to be included. 10 was going to be open like that. But we have got this bracket. Simply means that number is included. So that's why we are including it there. So this is the answer to the first part of the question. So you can do this to answer even the second part. So the second part which was saying, the second part is saying we have to find elements. So we are done with this. Don't know if we will need it again. Anyway, okay. So we have this real line. Then okay. So now the second part is saying A intersection B. So that is, you have to find elements which are common in A as well as in B. But for you to find that, you are first supposed to list elements of A. So let's use the real line. So we're going to have A starting from negative 1 included, so we have negative 1 included all the way to 4 also included. This is going to be A. Okay, so we have A there. What about B? B is starting from 0 not included, so I also had to include 0. I didn't see 0 as well as 9, so 0 will be between, okay, 0, we also have got 9, so let's say we have 9 there. Okay, so B is starting from 0, 0 not included, so open at 0 all the way to 9 not included, so this is going to be B. So now the question is, find A intersection B, elements which are common in A as well as in B. If you look at these two lines, where do they intersect? So they intersect at this part. So what is going to be our answer? So we're going to say A intersection B is going to be equal to 0 is not in B, so it's going to be open at 0 all the way to 4. As you can see, 4 is going to be in B, and also 4 is in A, so this is going to be included. Then answering it on the rule line, you are just supposed to extract this part and present it, also including the universal. So you're going to say negative 10, 0, 4 as well as 10. Then you present that part. 0 open at 0 and close at 4. That is going to be your A intersection. That will be your A intersection B. So you would have answered that question as well. Then we move on to this other part, which is part 3, A union C complement. So A union C complement simply means add A and C, and elements which then complement. Complement simply means elements which are not found in A union C. So when we add A and C, what are we going to get? Then which elements are going to remain, which will not be in A union C, but they are in the universal set? So what is A union C? So we have A there. Where is C? So C starts from negative 3 all the way to 6, whereas negative 3 is included. So close that negative 3, but 6 is not included, so it's open at 6. So this is C. That is C. Then we have A. Which question am I answering? No, it's B, not C. A union B. So this is supposed to be B. So where is B? B is starting from 0, not included, all the way to 9. Supposed to have 9 there, also not included, open like that. So when we add now, we are saying A union B. So add these. So when you add, you're going to find that you're going to have elements starting from negative 1 all the way to 9, but 9 will not be included. So this is going to be equal to negative 1 included to 9 not included. That is going to be A union B. So now we are saying complement. That is elements which are not found in A union B. So A union B complement is going to be equal to, so it's going to start from here, negative 1 not included, all the way to 10. 10 is negative 10. Negative 10 is not included. Also, starting from 9, 9 will be included in the complement because it's not in A union B. Then all the way to 10, also included. So this is going to be equal to negative 10 all the way to negative 1 open. Then union 9 will now be included in the complement all the way to 10, also included. Then you can just shade this part. That is your answer to that question. So this is what you can do to answer this question. This is what you can do to answer these questions. So maybe you can go ahead and answer part 4 as well as the last part. So these will require you to simplify. So let me just help you to simplify these two, then you are going to finish and send me the answers. So I have A intersection C minus this complement and complement. So as I said earlier, that superscript C there, it simply means complement, which can also be presented as this. So for you to answer this question, you are first supposed to simplify. So this is A intersection open C. So in mathematics, if you have A minus C, This simply means that A intersection C complement. So minus simply means intersection complement what comes after minus. So what we're going to have here, this is going to be C intersection B. You can see that B already has got a complement. So complement and complement, that will be positive. So this will just be B positive. Then we have a complement outside there. So for you to answer this question now, what you are supposed to do is you are supposed to find C intersection B, then complement. So elements which are not found in C as well as in B. Then those elements intersect them with A. They have to be common in A as well as in that set. Then, what else? Yeah. Then you'd have answered this question. So just find C intersection B. So C intersection B, where is B? B we already have it there. Then C is starting from -3 included all the way to 6 not included, like that. So that is C. So if we say C intersection B, C intersection B is going to be which part? So C intersection B will start from 0 all the way up to 6. So 0 not included. So C intersection B will be all the way from 0 not included up to 6. 6 also not included. Then complement elements which are not found in those sets. So it's going to be starting from 0 included now all the way to -10 not included. That is now I'm answering C intersection B complement. So be equal to -10 not included all the way to 0 included union. You also start from 6 will be included in the complement all the way to 10. So this will be union 6 included all the way to 10 also included. Then you can present that on the number line. Then you would have answered also this question. Then the last part, which is part 5. So we have X intersection. We have X. So remember that X is the universal set minus this. Then union open A minus B minus C complement. So simplify this. So simplifying this, we're going to get universal set intersection A complement union. This is going to be A intersection B complement intersection C complement. So C has got a complement already. So complement, that is going to be, remember I have C minus or B minus C complement. So this is the same as B intersection C complement. This complement and this one complement. So complement is positive. So this will just be B intersection C. So that is what we are going to have here, like this. Then now you are first supposed to start by finding A intersection B complement, elements which are found in A as well as in B complement. Then everything that you are going to have, intersect it with C. Then you have this. Then also find universal set intersection A complement, elements which are in the universal set but they are also in the A complement. Then after you find this, then combine together. That's what union means. Combine the element that you're going to get from here as well as there. Then after that, put your answer on the real line. Then you would have answered that question. So you can send me answers to that last part. I'll be waiting. Question 3, which reads, let R be the universal set and D be equal to that, E, F be that, be the universal set on X. So the universal set is R. So that R is the symbol for real numbers. So meaning that our universal set here is the set of real numbers. So real numbers is starting from any number starting from -infinity all the way up to +infinity. So that is going to be our universal set. Then we've got subset, which is D, E, F on X. So now we are saying that I think here let's first list the actual element or members of F. So we're saying that X is such that -10 is less than or equal to X, X is less than or equal to 10. So if we are to list this, F is going to be equal to, as you can see there, negative 10 is less than or equal to x, meaning that negative 10 is included. So we're going to use this. So that will be negative 10 all the way to 10, which is also included because we are saying less than or equal to 10. So it means 10 is also included. So we're going to have negative 10 included all the way up to 10. So this is set F. So now that we have these, we can answer these questions. So the question is saying display your results on the number line. So the first one being, so I said that always when answering this question, you're supposed to display all the elements given in the question on the number line. So let's say this is our number line. So we're going to have negative infinity this side. Then which number will come after that? So negative 10. Then let's say we have negative 10 here. Then after negative 10, we're going to have negative 7. After that, let's say we are going to have 0. We're going to have 0. Then let's say any positive number, we have 8. Okay, so we're going to have 8. Then we also have got 10. We also have got 11. Then we can say negative infinity. So now what we're going to do is we just put the members of interest. So this will be negative infinity at the universal, then all the way up to positive infinity. Then what is the smallest number after that? So we're going to have negative 10. After negative 10, negative 7. After this, I think we're going to have 0. After 0, what comes after that? So we're going to have 8. After 8, we have 10. Then we have 11. Then all the way up to positive infinity. So this is going to be our number line. So remember that the inverse set is denoted by x. So in short, what we have here, this is set x on the real numbers. They are all real numbers. So now we can start answering the questions. Now we can start answering the questions. So the first question being, okay, so the first question is saying we have to find f. So earlier on I already explained what this means. So this is the same as f minus e complement. So remember that complement is the same as f. So let's say we're going to have f minus e complement. So this now is going to change into intersection. So which will give us f intersection e. So there's a complement already there, another complement. So I said complement, they cancel each other. So that will just be f intersection e. So this is the first question, and we have to display it on the number line. So now we have to find f intersection e. So f intersection e, let's first have f. So f, we are saying it starts from negative 10 included. So it will be closed because it's included all the way to positive 10. This positive 10 will also be included. So this is going to be set f. Then what of e? So e, we are saying from 0 to 11, both not included. So 0 open at 0 and also open at 11. Like that. So that is set e. So now where do these two intersect? So you can see that the intersecting part is from 0 all the way up to 10. But is it going to be included? No. So it will be open at 0. So this is going to be open at 0 all the way to 10. So 10 is going to be included. Reason being, you can see that 10 is in set F. At the same time, 10 is also in set E. So this is set E. So for the fact that F is closed at 10, it means that 10 is included in F. Then you can see that this line for F, for E, is passing that 10. It means that 10 is also a member of E. But if you check 0 here, so we are saying that E will start from 0, but E does not include the 0. So that's why it's going to be open by there. Despite 0 being in set F, it's not included in set E. So that's why it's going to be open at 0 and closed at 10. So that is going to be your answer. So you can shade it like that, then leave your answer. You'll be marked correctly because you have presented your answer on the real line there. Then let's answer part 2. So part 2 is saying use the sets above to verify that D complement union E complement is the same as open bracket open D intersection E complement. What about it? So we'll start with the first one. So here we're just verifying is this true. So let's do this. Okay. So let's verify if that is true or not, if the two sides are the same. So we'll start with the first part, which is saying, so we have D complement union E complement. Oh no. So that is we have D complement union E complement as well. Then we are saying that this should be equal to open D intersection E complement. So I want to confirm if this is true. So okay, yeah. So the first part, D complement union E complement, yes. So let's first answer the first part, which is saying D complement union E complement. What is the result? So where is D? D is from -7. So let's have D. D is from -7, not included, all the way up to 8. So 8 is included in D. This is going to be D. Now what of D complement? What is going to be D complement? So D complement will be open at 8 and closed at 7. This one will go all the way to -infinity, and this one will go all the way to positive infinity. So this is D complement. This is also D complement. So now that we have D complement, let's come up with the E complement as well. So E runs from 0 to 11, both not included. So we're going to say 0, open at 0, and also open at 11, like this. So this is going to be E. So now we are saying that is going to be E. So we don't want E, we want E complement, because that is our interest. So now that we have E, then we can come up with E complement. So E complement is going to be closed at 11 all the way to positive infinity, and also closed at 0. 0 is going to be included in E complement all the way to negative infinity, like that. So now we have E complement as well as a D complement. So the question here is saying find D complement union E complement. So union, I said, simply means add. So we have to add D complement as well as E complement. What are we going to get? So if we add, we can see that E complement covers from 0 all the way to negative infinity. Okay? Whereas D complement starts from, so in short, this part of E which starts from 0 all the way up to negative infinity, it caters for D complement. So elements which are in D complement this side, they are also in E complement. So we're going to say that has been swallowed by E complement this side. So this side we're going to say it's from 0 included all the way to positive infinity. Then union, where else? So D complement also starts from 8. So in short, we are going to jump from 0 to 8. Then D complement starts from 8 all the way to positive infinity. So positive infinity, this side we also have got E complement. E complement starts from 11 all the way to positive infinity. So this part has also been swallowed by D complement. So since we are just adding, we are not finding the intersection, so we're going to say our final result is going to be negative infinity all the way to 0. 0 is going to be closed. Then union, also starting from 8. D complement is open at 8. So we're going to say union, this will be open, then 8 all the way to positive infinity. So this is going to be your answer. If you want to shade, you are going to shade like this, from there all the way up to that. Then you skip that part, then you also shade this part all the way to positive infinity. So this is the result for D complement union E complement. So now that we have the result for D complement union E complement, let's come up with, because remember that we are verifying. we are verifying if the two sides are equal. So now let's come up with the other set. So that other set is, what is it saying? So it's saying that we should also find D intersection E. So we should find D intersection E. So let's start with a D. So D, we are saying it runs from -7 not included all the way to 8 closed. So what we have here, in short, this is D. What about E now? So E runs from 0 not included, so it will be open at 0 all the way to 11. 11 also not included, closed at that part again. So like this. This is E. So now remember, this question is saying intersection. So we are now looking for the elements which are common in D as well as in E. So where the two lines intersect, intersect, that is where our solution is. So if you look at these two lines, the black and white, the black and red line, these two intersect from 0 all the way up to 8. This simply means that D intersection E is going to be equal to, you can see that it's open at the starting point of 0. So we're going to say this will be 0 all the way to D ends at 8. And 8 is included in D as well as 8 is also in E. So it will be closed like that. So this is going to be our D intersection E. So that part which is shaded there. So now we can go back to answer the question. Use the set above to verify this and that. So are the two sides equal? So if you look at these, you can already see that the two sides are not equal. So our final result is going to be, our conclusion is going to be D complement union E complement is not the same as D intersection E. So we have verified the two sides are not equal based on the results obtained. So the two sides are not equal. Then what about that other one? So what about the second one? So which is saying we have to find, okay, let me leave D there. So we now move to the other part, this part, which is saying D complement intersection E complement intersection F. Is it the same as that? Does it hold? Meaning that are the two sides the same? So here we have D complement intersection E complement. So I'm just going to explain this question, then you are going to finish based on how I've explained. So we have this is D complement intersection E complement, also intersection F complement. Is it the same as D union E union F complement? That is, if you add all the three sets, then the elements which will not be found in those sets when you add, but they are in the universal set. That's what it means. Then you are going to make a conclusion if the two sides are equal. So if you want to handle this first part, the first part you can handle it well if you can first start with 2. So let's say you start by finding D complement intersection E complement, of which we already found in the when answering this question. We found that D complement intersection E complement, even though that one was union, so now it's complement. Then when you find that, intersect it with F complement, then that is going to be the end result for this part. The same will be true this side. You can first start by finding two, or if you want this side, you can simplify by multiplying by that negative, so which is, or that complement, which is going to give you D complement union E complement. No, when you multiply by a complement, if it was union, we said that it's going to change to intersection. So this is going to be the same as D complement intersection E complement intersection F complement. So these two are the same. The top one and the down one, this and this, those two are the same. The other one is, I've just simplified it. So now that you have this, you can decide to handle 2 first. So you can say you find D complement intersection E complement, of which is the same as this, then intersect it with F. So here, if you look at this, the two sides are already equal. So we're also expecting your results to be the same, because after simplifying this, what we have obtained is exactly this one here. So that's the same there. So even your results that you are going to obtain, they should be the same. So that part is going to be, this part is going to qualify to be equal. So you can just go ahead and use this number line to verify this. So the two sides have to be equal. If you not find them to be equal, then you would have gone wrong somewhere. So you can drop your results so that we compare with what I have with me here. So question 4 reads, for each of the following sets, state whether it is finite or infinite, and in each case justify your answer. So we have to state whether any of these sets comes to an end, that is, it has got the beginning and the end, or it does not end. Okay, that's what infinity means, it does not end, or finite, it comes to an end. So we'll start with the first one, which is set B. So set B, we are saying that we have got counting numbers starting from 1 all the way up to 100. Now if you look at this set, you can see that you have the starting point. So you have the starting point is 1 and the end point is 100. So if you want to pick a member from this set, you are restricted. You can't pick a member which is less than 1. Also you can't pick a member which is greater than 100. So it means that this set, the first set is this one is finite because it's coming to an end. It has the beginning and the end. That is the justification. Then we come to part C, which is saying, so remember that this symbol simply means included. So this set C, we are saying you have members. If I draw the number line here, so that we understand this question better, we are going to have, let's say this is 1 and this is okay, so let's say we have this is going to be 0. Of course this is going to be 0, then this is going to be 1. Okay, so we are saying from 0 to 1 both included, so which simply means that it's going to be closed at 2. I just want us to understand what that means there. So close at 2 and also closed at 0 and also close at 1. This is this part. Then we are saying this part should now intersect with so we have this set 3 over 4 not included all the way up to 3 over 2. So if you divide, you are going to get that 3, how many times can 3 go into 4? So that is going to be 1 point, remainder will be 1 into 10, that is 3. Then remainder will be 1 into 10, another 3. So that is going to be something like 1.3. So where are we going to have 1.3? 1.3 is greater than 1. So let's say 1.3 is somewhere here. So this will be, let's say this will be 4 over 3. Then we also got 3 over 2. So what is 3 over 2 in decimal? So that is going to be, let's say 3 over 2, this will be equal to 3 into 2, that will be 1 point, remainder will be 1, 5. So this at least will be 1.5. So let's say 3 over 2 is there. Then now if you want to, we are going to say both are not included because we are using open symbols. So open here and also open there. Then we can join this. So the question that we have here is we want to find elements which are common in this set, but they are also in that set where the two intersect. We are looking for the intersecting part. So if you look at these two sets which we have here, they do not intersect at any point. This set is outside this other set, so they don't have common members. So this set is going to be an empty set. Okay, so C is simply equal to an empty set, and an empty set is a finite. Okay, an empty set is a finite set. So part C is also finite as well because it's an empty set. Empty set comes to an end. So the answer is finite for part C. Justification is that we don't have members which are common. As a result, this set is going to be empty. So an empty set is going to be finite as well. Then we move on to part D. So this set D is saying D is such that D is a member of then set D. So set D we have D is given by, so we're saying that X is such that is a member of real numbers. Then x squared plus x is greater than 2. So we have to state if this set is finity or infinity. So now if you look at that, let's just consider this. So that is an equality. So we're going to say that is x squared plus x is greater than 2. So if we rearrange this, we're going to have x squared plus x. That will be minus 2 is greater than 0. Then now this is a quadratic, so we can solve this as a quadratic. So we have product, sum, and factor. So product is negative 2. Sum is going to be 1. So what are the factors? Two numbers that we can multiply to get negative 2. We add, we get 1. So that is going to be 2 and negative 1. Okay. So then when we solve this, we are going to have x squared minus x, then plus 2x minus 2 will be greater than 0. Then we factorize, so we're going to have x is common, we'll remain with x minus 1. Then here common is 2, and we'll remain with x minus 1 is greater than 0. After this, now we are going to have x plus 2 is greater than 0. Then we also have x minus 1 is greater than 0. So this will be x will be greater than negative 2. Then we also have x will be greater than positive 1. So now we are supposed to test these. And in quality, when you find the values, you should always test the results so that you see where it's going to be defined, or yeah, it's going to be defined. So we're going to have this number, right? So let's say we have two numbers there. Let's say this is negative 2. Then this is going to be 1. So after this, what do we have? Okay, so this side is going to be positive, negative infinity. Then this side is going to go all the way up to positive infinity. So this result is saying that okay, so we have, what do we have? So we have, this is negative infinity, then we have negative 2, then we also have 1 here and positive infinity. So these values that we have obtained, these values are now what we call critical points. So we have x is equal to negative 2, then x equal to positive 1. So our interest is to test where, in which range of values is our solution is going to be greater than 2. Okay, so we're going to consider positive in that case. So what you're going to do with these critical values, you're going to reverse them and multiply the results. So that is going to be, if we reverse this, we are going to have x plus 2 multiplied by, that will be x minus 1, like this. So now let's consider any number which is less than negative 2. Let's say any number less than negative 2, let's say negative 3. Any number between negative 2 and 0, that is going to be, and 1, sorry, that is going to be 0. And any number greater than 1, so that is going to be, let's say 2. Here, you pick any number to the left hand side as well as to the right hand side, or the critical point. So you can see that we only got two critical points, negative 2 and 1. So you pick a number less than that critical point and also a number greater than that critical point. So less than negative 2, we're going to have negative 3. Greater than negative 2, we have 0. Then less than 1, we have 0. Greater than 1, we are going to have negative 2. So now we're going to use those numbers, the ones which are in red, and plug them in here and see the overall result that we're going to get. So here we're only interested, is the result going to be positive or negative? So let's say if we plug negative 3 here. If we put negative 3 here, we're going to have negative 1. So negative 1 multiplied by, we put negative 3 there, that will be negative 4. So the overall result, if you multiply negative 1 multiplied by negative 4, that is going to be positive 4. So it means if you get any number greater or less than negative 2, the result is going to be positive. What if now we plug in 0? We get a number which is less than, or which is greater than negative 2. That is 0. So we plug in 0, we are going to have, this will be 2. There we are going to have negative 1. If we multiply the 2, we are going to get negative 2. So overall result, we are just interested in the sign. It's going to be negative. What if you pick a number greater than 1? Say 2. So we plug in 2 now. So if we plug in 2, we're going to have 2 plus 2, that will be 4. Then 2 minus 1, that is going to be 1. So 4 multiplied by 1, that is 4 as well. So the result, overall result, that is positive. So now we know where the range of values where this function is going to be varied. So it's going to be varied for any number which is less than all the way from negative infinity up to 2. 2 won't be included, or negative 2. Negative 2 won't be included because there it's just greater than. If it was greater than or equal to, we are going to say it to be included. So we are saying it will be all the way from negative infinity up to negative 2, not included, union. So if you pick any number between negative 2 and 1, the result is going to be negative. That which means that the result that we are going to obtain, the number will be less than 2. So we don't want the number to be less than 2. We want a number to be greater than 2. So it means we're not interested in this area. Okay, so we are going to get a number which is greater than 1, and 1 won't be included. So we're going to say from 1 all the way to positive infinity. So for you to come up with this one, you use critical points, not these numbers. These numbers in red, they just help you to come up with or to decide what the outcome is going to be. So now this is our final result that we are obtaining. So now that we have found that this function is going to be defined in these areas, now we can state, is this set finite or infinite? Does it come to an end or it doesn't? So for the fact that we have got negative infinity and positive infinity, we are saying that we can pick any number starting from 1 all the way to positive infinity. You can also pick a number starting from negative 2 all the way to negative infinity. So this simply means that this set is infinite. It does not come to an end because it can be any number except these numbers here between negative 2 and 1. So this set is also finite, is infinity. So we found that this was finity, this was also finity. Then for the first time, D is infinity. It does not come to an end because of that. So that's how you can justify your answer to state if it's infinity or finity based on that, because this is an inequality. So that is it for that part. Then for the last part, is saying A is such that x is a member of real numbers. Then we have modulus of x minus 1 is equal to negative 1. Now, what's one thing do you know about the absolute value, or do you know about modulus? So modulus, what simply means is that anything outside modulus, it can't be negative. So if I have modulus of negative x is a positive x, whereas modulus of x, positive x, is the same as a positive x. Maybe let me use numbers. So modulus of negative 2 is equal to positive 2, and modulus of 2 is equal to also positive 2. So anything in the modulus, it can't come out negative. So for the fact that this question is telling us to say we have modulus of x minus 1 then equal to negative 1. So anything, then remember that x can be any number as long as it's a real number. Okay? Any number as long as that number is a real number, is a member of real numbers. So you can pick any number on the line, that can be your x. So we're saying that the result is going to come out negative 1. So this is not true. Something in the modulus can't come out negative. So this does not exist. This is false. This question is false. It does not exist. It does not have values which are going to make this set defined. So because of that, this set is going to be empty. It won't have members because this is not true. That is false. Anything in the modulus can come out negative. So it's an empty set. So for the fact that it's an empty set, it does not have members, it means it's finity. So this set, the last set, is going to be finity, to come to an end because it's an empty set, and this statement is not true at all because anything in the modulus can't come out negative. So that is how you would have justified this problem. So question 5, we have another very interesting problem. So let's do with it. Let U be a set that is the universal set such that x is a member of natural numbers. So you know that natural numbers, these are counting numbers starting from positive 1. So 1, 2, 3, 4, 5, and so on. So now in these natural numbers, we are saying that this set complies numbers starting from 1. 1 is included because we are saying this set has got members starting from 1 less than or equal to, meaning that 1 is also included, all the way up to 30. So 30 is also included because we are saying less than or equal to 30. So now what we have here, the universal set has got members, that is 1, 2, all the way up to 30. So this is our universal set. Then we move on, given that A is, so this is going to be a subset of the universal set, such that X is, okay, so let's understand this part. Okay, because we have to interpret and come up with the actual members of that set. So we are saying that X is such that X is equal to 2k plus 1. So what is the condition? So remember that we have this part. This part is saying k is a member of natural numbers. But remember that this is in the set of what? The universal set is starting from 1 to 30. So meaning that k can be any member from this set. Okay, not outside the universal set, because we are restricted by the universal set. So k is a member of natural numbers. But again, there is this condition here. We are saying that k is any member but less than 15. Okay, less than 15. So what does it mean? So meaning that k is going to be any member. So we're going to have k equal to 1. Also k will be equal to 2, all the way up to less than 15. So that is going to be k will be equal to 14. Okay, so we have k is all the way from 1 up to 14. These are the values of k. So it can be any number starting from 1 to 14. That is going to be k. But now we are saying that for you to get x, set x or set a, so a will be equal to, okay, a is going to be equal to, you have to start from 1, put let k be 1, so put k where the where 1 where there is k, so that is going to be 2 multiplied by 1, it to be 2, so 2 plus 1, that is going to be 3. So the first member of set a is going to be 3. Okay, 3. Then the next member k will be 2. 2 multiplied by 2, that is going to be 4. 4 plus 1, that is going to be 5. The next we are going to have, so I want you to observe the pattern that we're going to have here. The next we are going to have 3. 2 multiplied by 3, that is going to be 6. 6 plus 1, that is 7. The next we are going to have 5. So 5 multiplied by 2, that is 10. 10 plus 1, that is going to be 11. So if you have noticed, we are obtaining odd numbers. Okay, we are obtaining odd numbers. So how many are they going to be? So I was on 5. I was on 5. The next we are going to have 6. So 6 is going to be 6 multiplied by 2, that is 12. 12 plus 1, we are obtaining 13. Then 7 multiplied by 2, that is going to be 14. 14 plus 1, we have 15. Then 8 multiplied by that, 16 plus 1, that is 17. Then 9, 18 plus 1, we have 19. Then 10, that is going to be 20 plus 1, we're going to have 21. Then 11, that will be 22 plus 1, we have a 23. Then next we're going to have, I'm on 11, so 12, that will be 24 plus 2, we have 25. Then 13, 26 plus 2, that is going to be 20, plus 1. 26 plus 1, that is 27. Then next we have 14, that is 28 plus 1, that is going to be 29. So it means that we are done. This is set A. Okay? So these are the members. I've listed all the members of set A. So that is how you can come up with this set. Just use this formula. So the logic was you knowing what the value of k is and where are you going to get this k. And remember that the universal set runs from 1 to 30. So we are not expecting to have a member outside the universal set. That is why k there, they are saying k is less than 15. So that if you put k as 15, let's just try. If we say k is 15, 2 multiplied by 15, that is going to be 30. 30 plus 1 to be 31. So 31 will be outside this set. That's why we have that condition there. So all these are going to be members of set A. Then also set B is complete. So we have B, which is straightforward. Let's just bring it here. So B equal to, that is 1, 3, 8, we have 19, then 20. Okay, that is it. Then we also have got set C. So set C, what is it saying? So C, x is such that x is equal to k squared. So this one again we are supposed to calculate. So we are saying that for you to obtain x, this will be equal to k squared. What is the condition for k? So k should be a member of natural numbers in the universal set, but k should now be what? Less than 6. Okay? K should be less than 6. Meaning that the value for k are going to be, k will be equal to 1, 2, 3, 4, and 5, because we are saying k should be less than 6. So now using this formula, let's come up with set C. So set C is going to be equal to, we start, if k is 1, what is going to be x? So 1 squared is still 1, so we have 1. Then 2 squared is going to be 4. 3 squared, that will be 9. 4 squared, that will be 16. Then 5 squared, that is going to be 25. Then this is the set C, because we are saying k should be less than 6. So if you put 6 there, it's going to be 6 squared 36. 36 will be outside this set. That's why the condition is also k should be less than 6. Okay, so we have set C. Then lastly we have set D, which is already given. So D is equal to, D we have members, that is 1, 2, 6. So we have 1, 2, 6, then 8, 11, and 15. So now we have all the sets in their simplest form, so we can answer these questions now. So this is more like just a repetition. What was hard, it was just this part for you to come up with these sets, like set A, set and set C, as well as maybe the universal set. So now that we've come up with all these sets, I do believe that you can answer all these questions. So I'll just pick one and try to answer. So let me answer part 2. Then you are going to answer part 1 or all these remaining ones. So we have A, that is the difference of set, then B union C. So that is difference of the set, which simply means A minus open B union C, like that. So this will be A intersection open B union what comes after that, we have a complement. So this means that we already have set A. Set A, where is it? So set A is here. So now we want to find members which are common in this set, but those members should also be found in B union C complement. Okay, they should also be found in B union C complement. So let's come up with that set, B union C complement. So members which are not found in B union C. When we add B and C, the members which are not going to be found in that set, but they are in the universal set. So where is B and C? So B and C, we have 1. So we're going to have 1, then 3, 4, 8, 9. Okay, let me write it somewhere. So we are saying B union C will be equal to, B union C, we are going just to combine 1, then 3, we have 4, then 8, the next we have 9, then 16, 19, then we have 20, and lastly we have 25, like this. Okay, so now complement simply means any element now which is missing in this set, but that element is in the universal set. So what is missing there? We have 2 is missing, 3, 4, 5 is missing, 6 and 7 they are missing, 10 is missing, then 11, 12, 13, 14, as well as 15, then 16 is there, 17 is missing, 18 is missing, 19 is there, so we have 21 is missing, then 20, 21, then 20, 22 is not there, 22, 23, 24, 25 is there, then we have 26, so all the elements there up to 30. So this is our B union C complement. These are the members. So now the question is, the question we are answering is elements which are common in A, but they are also in B union C complement. So let's see which elements are common in these two sets. So let me have it here. So we have A intersection open, B union C complement. So we're saying this will be equal to open. So each element are common there. So where is set A? Set A is here. So you can see that set A is a very big set as well. So which elements are common? We have 3 here, we don't have 3, 5. So 5 is the first element, so we have 5. Then 7 is also common. Then 11 is common. Then 13 is common. Then 15 as well is common. Then what else? 17, yes, is common. Then 19 is not common. 19 is not in B union C complement. Then 21 is common. So we have 21 is common. 23 is common as well. Then 25 is not common because it's not in the other set. 27 and 29. So 27 is common as well as 29. So this set is okay. So this is the answer to this question. That's our answer. A intersection open, B union C complement. The result is this one there. Okay. So you can go ahead and find this one, that one, and this one as well. So these are very simple. Just simplify. So you're going to simplify this one or this, then you are going to answer this question. So let me just help you to simplify part 3, then I'm going to leave everything in your hands so that you can answer them. You can share what the solutions are going to be. Should I simplify? Let me simplify part 3. So we have open A union B, then intersection C, then complement outside. So here we're going to go ahead and say this is the same as if you have a complement outside, you are always allowed to multiply to open these brackets. So this is going to be A union B, then complement. So when you're multiplying a complement by whatever you have inside, if you have union here, this is going to change to intersection. If it was intersection the way it is here, it will change to union. So this one will now be union, then C complement. So this is the final result when you simplify that one. Then now you can go ahead and find A union B complement. Elements which are in the universal but they are not in A union B. Then add elements which are not in C. Then you combine the two sets together. That is going to be your final result here. So go ahead and answer these remaining questions. Question 6. So question 6 is saying, in each of the Venn diagrams below, figure 1. So we have figure 1, which are these two. Shade each of the following separately. So we have to shade each one of these separately. So what it means here is that for this one, you're going to use this diagram as well as that. So what's the difference between these two? The difference is that if you check on this one, Z is a subset of Y. Whereas here we don't have subset. Any set is not a subset of the other except from the universal. So you have to answer that question on both of these two diagrams, but we are supposed to shade. So let's start with the first one. So the first one we have x minus y. This symbol we said that it means the difference of the set. So y, that is the same as x minus y. So x minus y is the same as x intersection y, then this will take the complement. So we have x intersection y. So elements which are found in x as well as in y complement. That's what we are looking for. So usually with me to answer this question, most of the times I use numbers. So we're just going to assign one number in each of these. So let's say we have 1 here, then 2, 3, 4, 5, 6, 7, then we have 8 outside there. So let's start listing the elements there. So we have x. So x is going to be equal to which elements are found in x. So you can see that x takes up elements starting from 1. Then we have 3, 4, and 5. X will end there. You can check. So that is going to be x. Then now we are looking at, we should also find y complement. So y complement, these are elements which are not found in y, but they're in the universal set. So where is y? Y is this. So every element which is in y will not be included. So we'll just remain with these also plus that. That is going to be y complement. So let's say we have, that is going to be 4, 5, 6, and 8. This will be y complement. So now to answer the question, we are saying that we are looking for elements which are common in x, but they are also in y complement. So now let's check which elements are common in x as well as in y complement. So 1 is not in y complement, 3 is not in y complement, but 4. So 4 is in x as well as in y complement. What else? We also have got 5. So 5 is also in y complement as well as in x. That's all. So what do we have? We just have 4 and 5, which are common in these two sets. So we have 4 and 5. So meaning that x intersection y complement, the result is 4 and 5. Then now for you to answer, because you are supposed to shade here. So for shading, you are just going to shade where you can see 4 and 5. So our answer to this question, to answer this question now, we're going to say the answer is this part all the way up to that. So you would have answered this question. That is the answer. So this is how I find it easy to answer these questions involving shading. Just using numbers is very easy. Okay. So I've answered the first part. What about the second part? So the second part, so when I answer this second part, I also expect you to answer this third part as well as that. Okay, so we have this. Okay, so also remember that you are supposed to answer this x minus y also on this. Now that z is a member of y, z is a subset of y, how are you going to shade? How are you going to shade? So in this case, we are just dealing with two sets, x and y. So you can ignore z. You can ignore z because z is not involved there. But let's see this second question, which has got all the three. So to simplify that one, we're going to say we have x minus open y union z. So this is going to be the same as x intersection open y union z, then we'll have a complement. So when you have got a minus, whatever comes after that is going to be a complement. For the fact that these are in brackets, you treat these as one. So that's why the complement will come on top like that. So this is what we're going to have. So let's do the same. Okay, let's do the same to assign numbers. So let's say we have 1, then we have got 2, 3, 4, 5, 6, 7, and 8. So the first part, the complicated part, is going to be this one. Let's find this one first. So we're saying y union z complement. But for you to answer y union z complement, you should first just focus on the inside part. Ignore about the complement. So we're going to say y union z, this will be equal to, so which elements, when union simply means add. So let's add elements in y as well as in z. So we're going to have 2, 3, 4, 5, 6, 7. So this will give us 2, 3, 4, 5, 6, 7. So now then we can answer the complement part. So the complement part, now we are saying we should, so we want now to get y union z, so complements. Complement simply means when you add the elements, these two elements which are not going to be found in those two sets, but they are in the universal set. So let's exclude these elements. Everything that remains is going to be Y union Z complement. So what remains, we're going to have 1 and 8 only. Yeah, we're only going to have 1 and 8. So we're going to say this will be equal to 1, 8, like that. So now that we have Y union Z complement, we can now then find the shaded part. What is X? So let's list X as well. So X, we are saying we have 1, 2, 3, and 4. 1, 2, 3, and 4. That is our X. So now we want to find the intersection. Elements which are common in this set, they are also common in that set. So which numbers can you see that they appear in both of these two sets? So it's just 1. You can see 1 there. You can also see 1 in X. So now this means that X intersection open Y union Z complement using numbers, this is going to be equal to 1. So now go shade where you see 1 just. So 1 is seen in this part. Okay? Just that part. So this is the answer to the second part. So do the same, simplify this one and do the same approach. The same with this one as well as that. So maybe okay, let me do this. Okay, so we should answer this same question on I'm going to use this same question to answer it on using this other Venn diagram, which has got different arrangement from this one here. So now we have got Z is a subset of Y. So remember, let's still assign the numbers. So let's say we have 1, 2, 3, then 4, and 5. So we have Y or X minus Y union Z. So this is the same as X intersection open Y union Z then complement. So using this second diagram, the Venn diagram, let's first come up with Y union Z. So Y union Z using the second diagram or Venn diagram, we're going to have where is Z? Z is A inside, so we're going to have 2, 3, and 1. So this will give us 2, 3, and 1. Let me put them in ascending order. So 1, 2, and 3. So that is going to be Y union Z. So now what we want to find is Y union Z complement. Elements which are in the universal set but they are not found in Y union Z. That's what Y union Z complement means. So you can see that we're only going to remain with 4 and 5. These are the only going to be elements which will not be found in Y union Z. So we have 4 and 5. So that is where our interest is. So now intersect that with X. Elements which are found in X. So what is X? So X is equal to, X we have got 4 and 5, or 3 and 4. Because X is this set. So let's list the elements of X. So we're going to have 3, 4, like that. So now what is common in this set? What is common in this set and also in this set? So we can see that only 4 is common. So now then we are going to say X intersection open Y union Z complement is equal to what is common. So we found that common is 4. It's just 4. So for shading now you can go ahead and just shade where you can see 4. So 4 is there, meaning that your answer to this question is going to be that part. That's the part which we are going to shade. So now that you are going to report these as your final results, these numbers should not appear as they go to the marker. This, you can do this on the rough paper. On your answer sheet which you are going to submit, just go ahead, don't show these numbers, then just shade that part. Just shade that part. This is your own trick. This is how easy I find to answer these questions. So you can answer any of these questions here. Any of these questions. So I want you to answer part 3, part 4, as well as part 5. Let me maybe for the last time answer which part? For the last time, okay, let me answer part 4. So I'll answer this part 4, then for you are going to answer the last two parts, that is part 5 and 6. So 4, so this requires you just to simplify. Once you simplify, you're going to find that it's very easy. So that part 4 is saying x intersection open, y intersection, z complement. We also have got a complement outside. So go ahead and simplify first, because you can't answer like that. So we're going to have, this will be x intersection open, this is going to be y. So now we're going to multiply everything by this complement which is outside. So this will become y complement. Once you multiply by a complement from outside, whatever you have here has to change. So it was intersection, now it will be union. Then z complement. So this z already has got a complement. So complement, we said these are going to cancel. That will just be z. So we're just going to have y complement union z. So like this. This complement has already been used. So this is going to be our final result. Then now you just assign numbers in these sets. So let's say we have 1, 2, 3, 4, 5, 6, and 7. So x, we already know the elements for x. So x, we have x is equal to, we have got 1, 2, 3, and 4. That is x. So we should now find y complement union z. This requires us first to find the elements of y complement. So y complement will be elements which are in the universal set, but they are not in y. So exclude elements which are around this, because that's y. So everything outside that, which is going to be 1, 4, 5, and 8. So this will be 1, 4, 5, and 8. This is going to be y complement. So now union simply means add z. Union simply means add. So to whatever we have there, let's add z. So our final results, what we are getting, we are going to say y complement union z. This will be equal to, so where is z? So z has got elements which include the 3, 4, 5, and 6. So let's add to that. So we're going to have 1, then 3, 4, 5, and 6. Then we also have got 8 in y complement. So this will go all the way up to 8. So y complement union z, we have this. So now remember, the question that we are answering is x intersection whatever we have now. So let's see the elements which are common in x and also in this set. So which elements are those? Let's go ahead and list those elements. So we are going to see that 1 is in x as well as in this set. So the first one, we have 1. What else? Do we have 2? We don't have in here, but 3. We have 3 here. We also have got 3 there. So 3 is the second element. So we have 3. What else? So 4. 4 is also common in y complement union z as well as in x. So we also have got 4. That is all because set x ends up to 4. So these are going to be the elements. So now go ahead and shade where you can see 1, 3, and 4. So 1, 3, and 4. That is your answer. So 1, 3, and 4, you can see that this is going to be 1, 3, and 4. Yes, including this part, 1, 3, and 4. So this is going to be your answer. So that is the answer to this question using this first Venn diagram. So that's how easy you can find these using numbers. Then you do the same on this other one. So you're going to assign numbers 1, 2, 3, 4, 5. It doesn't matter. If you want, you can use alphabetical letters. Let's say A, B, C, D, or whatever. These are just going to help you, like which part are you supposed to shade. So remember that we have we said x intersection y complement union z. When you simplify this, that is what we got. So what is now going to be y complement union z? So let's first come up with y complement using that set now. So y complement is going to be equal to elements which are not found in Y. So where is Y? Y has got elements 1, 2, and 3. So elements which are not found in Y is just 4 and 5. So we're going to say this will be 4 and 5. Then what about Y complement union Z? So when we say union, simply means add. So now let's add elements which are in Y complement and also in Z. So that is going to give us, so Z has got elements 2 and 3. So let's add 2 and 3 to what we have there. So that is going to be 2, 3, then 4, and 5. So this is going to be Y complement union Z. That is Y complement union Z. Then now to answer the question, let's intersect whatever we have here with X. Which elements are going to be common in X as well as in that set? So what is X? So X we have that as 3 and 4. So which elements are common in these two sets? It's 3 and 4, meaning that this whole thing is just equal to X. Okay? Because you can see that we have got 3 in this set, we also have got 3 there. We have 4 there, we also have got 4 there. So if you look at the 3 and 4, 3 and 4 is set X. So simply mean that to answer this question using this second Venn diagram, for you to shade, you are going to shade this part where you can see those numbers. So this is going to be the answer on this second Venn diagram. So now that you have an idea, go ahead and answer part 5 as well as part 6. So you should first start by simplifying. After you simplify, then assign these numbers, then you answer. So you can drop your solution that you are going to find so that we can compare with what I have. Okay, so for part B now they have shaded for you and you have to describe the shaded part. Instead of you shading, they have shaded for you and describe the shaded part. Previously we are given a description, then we are supposed to shade. So in each of the Venn diagrams, use the set operation. So it was supposed to be use the set operations, union, and or intersection and complementation to describe the shaded regions. So you can only use union, intersection, or complement to describe the shaded region. So the first part we have this. So what we are describing here, we are describing this shaded part where B is. So if you check there, what this describes is these elements are not in A. So elements which are not in A, that is going to be A complement. Then intersection B. So this is going to be A complement, intersection B. Let's verify if this is true. So let's assign numbers 1, 2, 3, let's say 4. What is A complement? So A complement is going to be equal to elements which are not in A. So that is going to be equal to 3 and 4 only. Then let's come up with set B. Set B will be equal to, we have 2 and 4, or 2 and 3. So this will be 2, 3. Then what is common? So what is common in A complement and also in B? So elements which are common in these two is 4. So where is 4? 4 is in B. So indeed that is true. So the answer to the first part is A complement intersection B. Elements which are common in A complement as well as those elements are in B. Then we come to the second part. So the second part, which is part 2, what are we going to have there? So this part 2, you can see that here we have now elements outside A. That white part simply means elements not in that set. So that is going to be, the starting point is A complement. A complement now, elements outside A. So element outside A is going to be everything, okay? Everything there, except this part. So you can see that this part is also shaded. So it's the one which is remaining now here. So how are we going to involve that part? So to involve that part, you can see that that part is part of B. So this is going to be A complement union B. So that is going to be the answer there. If you want, you can still use numbers to just confirm if this is true. So if you say 1, 2, 3, and 4, these numbers I'm just using them for the sake of being sure if the answer that we have is true. So what is A complement? So any element outside A, that is going to be 3 and 4. Then what about B? So B is going to be equal to, B we have 2 and 4. No, 2 and 3. So B is 2 and 3. Then now we are saying we should add A complement union B. So add those two. What are we going to get? So when we add, we're going to have 2, 3, comma 4. That is the part which should be shaded. So where 2 is, it's here shaded. Where 3 is also shaded. Where 4 is also shaded. So the answer is going to be A complement union B for the second part. Then we move on to the third part. So this part now, you can see that this shaded, this area, the white area in A, that part simply means that elements not in that set. Okay. Then B also elements not in that set. So we are describing the shaded part. If you look at this shaded part, this is the intersection. So we are saying that that intersection. So we can say that this is going to be, but again, this shaded part outside here, these are going to be elements which are not in any of these two sets. Those are going to be elements which are not in any of the two sets. So what are we going to say? Elements which are outside the two sets. So elements which are outside two sets, we're going to say that is going to be A union B. You add the elements in A and B, then complement. So when you add the elements in A and B, complement, which simply means bring together all the elements in A and B, then elements outside A and B. So if you have A and B, you add together elements that are not going to be in A and B, is going to be this part outside here. So we have answered the first part. Now we want also to involve this part. The intersection part is involved. So that being part of the shaded part or the interest, we're going to say this also we should add. So union, what are we adding? We are adding A intersection B. So this is going to be the final answer. So A union B complement describing the outside part. Intersection or union, we should add to whatever we have, we should add A intersection B. So this is going to be the answer to part 3. So if you want, you can go ahead and to verify these using numbers, but you should get the same answer. So I'll just answer one more, then you are going to finish the remaining 2. Okay. So we come to part 4. So part 4 we have so part 4 we have this one here, A, B, and C. So now we have 3 sets. So how do you describe these 3 sets which we have? How are you going to describe them? So let's start. So here we have A, B, and C. So you cannot involve, it's possible you can involve all of them at once, but again, it's possible that you use 2, then you add the other one. So this one is going to be, how is it going to be? So which part are we going to start with? So what are we describing here? We are describing the shaded part. We are describing the shaded part. So if you look at this, the white part here, let's consider just B and C, forget about A. So if you consider B and C, they are only leaving their intersection. This intersection part is the one which is not involved. So what are you going to say there? So if you look at that comma part between B and C, you're going to say B union C, you add the B and C complement. Not union, no. Not union, so that should be that comma white part. So that is going to be B intersection C. So B intersection C, that is not our interest. B intersection C is the white part. So elements which are not found in that white part are what we're interested with. So B intersection C complement. So elements which are not found in B intersection C, that is our interest. So that is going to be any element outside, every element outside that part. Okay, every element outside that part. This is what B intersection C mean there. So now we want to add to whatever we have there. Remember that we also have got A. How are we going to involve A? Because if we leave it like that, it would mean that this part was also supposed to be shaded for A. But it's not shaded. So we want to exclude that part of A now. So how are we going to exclude that part? this is also going to be, then this now is going to be, we should add elements which are found in A, in A complement. So A complement, these are going to be elements not found in A. So elements, any element outside A, any element outside A. So if you involve any element outside A, you're going to find that this part is going to be shaded. So this white part has already been taken up by that part. Then when we add the A, we are going to use that. So we're going to have B intersection C complement, then union A complement as well. So that is what we're going to get for this question. Then we have the fifth one and sixth. So I'll not finish all of these. So I'll end on, you are going to answer the last one, which is part 6. Let's answer this part 5. So part 5, we also got A, B, and C. So A and B, first let's consider A. All the elements in A are included. So this is going to be, you can start with considering A and C. So if you consider A and C, this is going to be A union C. Okay, so if you add A union C, even this part was supposed to be shaded. So we're going to say A union C. Then now let's forget about A. Let's focus on B and C. So B and C is excluding their intersection. If you see here, this is excluding intersection. So we're going to say to whatever we have there, we should add. So this is going to be union, open, B intersection C. This one now should complement. So add elements in A and C. So you're going to have everything shaded. Then now come to these sets B and C. So if we want to describe this gamma white part, this gamma white part is not included, but what is this gamma white part? So it's a B intersection C. So elements which are not found in that gamma part, B intersection C, then you just add a complement. So that is going to be the answer. So if you want, you can go ahead and use numbers. So you should get the same results if you use numbers there. Where we have got these shaded parts, that's where your numbers should be. So you can answer this last part and send your solution so that we can compare. So question 7, which reads, given that P and Q are disjoint sets, simplify P complement union Q complement. So here we are supposed to simplify. Okay, just make it simple. So another key term there is going to be disjoint. So disjoint simply means that these two sets do not intersect. Okay, so if we are to draw a Venn diagram and present those two sets, it's going to be like this. So this is the inverse, so then you're going to have, let's say this is P, then this is Q. Then we have the inverse there. That is the inverse, so then this is going to be, let's say P, that is going to be Q. Then let's just assign elements. Let's say 1, 2, then we also got 3 in the universal, like that. So from here now, we can go ahead and simplify. That is P complement union Q complement. So this one is a bit more simplified, but we have to be very sure, like we have to reach at the final, what is going to be the final result, the overall final result. So using these elements, let's come up with a P complement. So P complements, these are elements which are not going to be found in P, but in the inverse. So that is going to include 2 and 3 only. Then Q complement as well, this is going to be equal to elements which are in the inverse, but they are not in Q. So that is going to be 1 and 3. 1 and 3. But then we are saying union. So union simply means add. So let's add P complement and Q complement. So that is P complement union Q complement. This is going to give us, so the overall is going to be 1, 2, 3. We are just adding. So this is the final result. But then remember that we are simplifying. We are not interested in what elements are we going to obtain. So if you look at this 1, 2, 3, which set has got elements 1, 2, 3? So that is the universal set. So this simply means that simplifying P complement union Q complement further, this is just going to be equal to the universal set. So universal set is presented by that symbol O. You can use this. So I'm avoiding to use this because someone will look at this as union. So that is P complement union Q complement is giving us the entire universal set. So that the final result is going to be the universal set. So that's the final result. So I'm using this Venn diagram just for me to be sure of the final result that we're going to obtain. Because I mean, that is very simplified, like P complement union Q complement. What step are you going to take for you to simplify this one? It will be very hard. So that's why, like, if you introduce Venn diagram, it's going to guide you much better. Then the second part, which is part B, saying given that X and Y are any two sets, express the following in its simplest form. So we are supposed to simplify these sets and leave them in their simplest form. So the first part, which is saying X complement intersection open X union Y complement. So remember that if I have X to that is the same as X complement. So I'm very much used to using that complement than this C because I can confuse this C with a particular letter. So let's simplify this. Okay, so it's already simplified though, but then from there let's introduce the Venn diagram so that we see what that one is going to be. So here we have got sets just X and Y, and these two sets they intersect. They at least have got elements in common. So this is going to, let's say universal, this is X, that is Y. Then let's come up with our own elements. Then let's say 1, 2, 3, and 4. So from there we are supposed to have elements that is X complement. So X complement, elements which are in the universal but they are not in X. So that is going to be just 3 and 4. Okay? Then now let's come up with X union Y. So X union Y, this is going to be add elements in X and Y. So X and Y, when you add, we're going to have 1, 2, and 3. Then we are saying our interest is X union Y complement. So elements which are not found in this set, but they are in the universal. So except 1, 2, and 3. So we're only going to remain with 4. Okay, we're just going to remain with 4. So now that we have both X complement as well as this, let's find the intersecting elements. So which elements are common in those two sets? So if you look at this, we have 4 there. We also got 4 in X complement. So it means that only 4 is common in these two sets. So now go ahead and check where 4 is. So 4 is outside these two sets, X and Y. So how are you going to simplify this one further? So if you look at this 4 is outside X and Y, which simply means that this can be X union Y, then elements which are not found in X union Y, so complement. So the final result, or simplifying that one further, the final result is going to be just X union Y, then everything complement. So that is the final result. So you can see that using the Venn diagram, it's much easier to tell you the final result than just simplifying. Then, okay, so using that concept, you can answer this part. Just find X intersection Y, also find X intersection Y complement, then add. Then when you add, use the Venn diagram and see what is going to be the actual final result. So let me jump to part 3, which is saying we have X complement, the intersection Y complement, and another complement outside. So for this one here, we have complements inside as well as outside. So in mathematics or in set theory, if you have got a complement there and the other complement inside, you are always supposed to multiply. so that we can open these brackets. So remember that we have got x complement, so that is going to be x. So x complement multiplied by complement is just equal to x. So that is just going to be equal to x. So always when a complement is multiplied by elements inside the set or inside, whatever you have here is going to change. If it was union, it will be intersection. If it was intersection, it will be union. So now that we had intersection, this one now will change to union. The same will be true. Y is carrying a complement. Complement, that will be just y. So this will be x union y. So this is the final result. You cannot reduce this one further. So simply means just add elements in x as well as in y. So that's what this set is all about. So this is the final result. You would have simplified. So it's very simple. Then let me also deal with this part 5, which maybe it may confuse you. So let's go ahead. We have x intersection y, then union open x minus y, then we have complement. So to answer this question, we are supposed to simplify. So we'll start by simplifying that part. So this is going to give us open x intersection y, then union open, this is x minus y, then we have a complement outside. So x minus y, that is the same as x intersection y complement. I've already explained how that is coming about. So this is now going to be open x intersection y, then union open x intersection y complement, then remember that we have another complement outside. So at this point on our next stage, this complement should multiply by everything inside. So we're going to say these brackets will be removed. So now we are going to just have x intersection y, then that complement will come here. So remember, when you're multiplying by a complement, this will change now. So it was union, it will now be intersection. Then this is going to be x intersection y complement. So we can't have a complement inside and outside. There you are also supposed to simplify further. So here we are okay because we don't have a complement inside. So we can just bring this one down. That will be x intersection y, then complement intersection open. So now this complement is multiplied by everything inside. So this will give us x complement. Remember, this was intersection, so it will change to union. Y complement multiplied by complement, that is just y. So this is going to be equal to just y, like this. So now we'll not be very much sure if this is the final result. So what are we supposed to do at this point? Let's introduce the Venn diagram. So you have reached a point or at a stage where, let's say, you have 2 over 4. If they tell you to say simplify this one further, you can't leave your answer there because there is a number which can go into 2 as well as in 4. So there you are supposed to use 2, that is going to be half. So this is the most simplified form. That's what they want to see. So at this stage we are not very much sure if we have reached at this point, or maybe we are there. So there is still a step that we can take. So this is where now we are going to introduce the Venn diagram. So in the Venn diagram, we just have two sets, x and y. So these x and y, they are intersecting. And then let's say this is universal, we have x and that is y. Then let's say elements, we have 1, 2, 3, 4. Okay, just like that. So now let's start listing the elements that we have. So let's start with x intersection y complement. So x intersection y complement simply means elements which are not found in the intersection. So we only have got 3 in the intersection. So every element which is not in the intersection, that is x intersection y complement. So this will be our final result. Also, let's answer this part. Then this is going to give us that one also demands us first to come up with x complement. So what is x complement? Elements which are not found in x but in the universal. So that is 1, 4. Okay. Then this one now union y. So let's add y there. So x complement union y. So when we add y there, we're going to have that is going to be 1, 1 comma 4. Yeah, it will just be 1 comma 4. So 1 comma 4, this is the result for x complement union y. So what are we looking for? So what we are looking for now, we are looking for x intersection y complement, which is this set, union x complement union y. X complement union y. Okay, so union y will also have 3. I forgot that because we are adding, we are just adding. So 3 is in y. So 1, 3, and 4. That is going to be x complement union y. Then, which elements are common in this set as well as in this set? So you can see that it's just 1 and 4. That is just 1 and 4. So we have 1 and 4 as our final result. Now let's check where is 1 and 4 in our set, in the set. So 1 is in the universal, whereas 4 is part of y. So if we are asked to shade, our final result was going to be like this. But now here we are being asked to just simplify. So simplifying this one, we cannot describe that shaded part because we have got an element in the universal set which is outside x and y, but this part is also taken up. Okay, so we're just going to say our final result will end there. But in a case, let's say this just gave us 1. If it just gave us 1, we are going to say that would have been x union y, then everything complement, this part outside there. But because we're including that, this will not be qualified, so we'll just leave it there. So that is going to be our final result to this is part 5. Then part 6 you can answer. So part 6 is already simplified. Just go ahead and answer this question. So you have x intersection y union x intersection y complements. Just simplify. After you simplify, then introduce the Venn diagram, then get to see what you are going to have as your final result. The same will be true with part 7. It's also already simplified. No need for you to stress. So just that here we have got 3 parts. So you have x intersection y union x intersection y complement, also union x complement union y. So for you to answer this question very well, you should do first treat 2. Okay, from there to here. So first find this union that, so that this can give you a single set. So that when this gives you a single set, you are now going to add that. Then that is going to be your final result. So go ahead and answer that part. Then you can drop your solutions in the comment section.
So I believe you are enjoying this video. So if you want to access the full solutions for this tutorial sheet, check the link in the description below. Then you will be able to access it from the website. Okay, so register with us at an affordable price. You'll be able to access all the questions here with detailed explanation that can help you to understand set theory, functions, as well as binary operation. Okay, so in a case where you want to get in touch with us, you can text us using this number on WhatsApp. This is the number for the customer service for Transcended. So let me just recheck it. +26 097 0979 58 0034. So this number is active on WhatsApp only. If at all you want to call, you can use this number 0767 72 9927. So this one is only for calls, it's not on WhatsApp. Then this one is on WhatsApp if at all you want to get in touch with us on WhatsApp, but I would prefer you to text this number on WhatsApp. Okay, so don't waste your time. Register with us. Start your NS journey with Transcended. Let's transcend together. Thank you.